Hello everyone, welcome first year students English section, Faculty of Commerce at City University. This is Reem Sobhi. I'm a teaching assistant at Insurance Statistics and Mathematics Department. This is section 5 in Descriptive Statistics course on chapter 2 titled Frequency Tables. In the last sections, we already defined the types of the frequency tables, and we know that there is 3 types of the frequency tables. Frequency tables according to the type of the variable, and there is 3 types of frequency tables: qualitative frequency tables and frequency tables for quantitative discrete variable and frequency tables for quantitative continuous variables. The second types of tables are the tables according to the numbers of variables, and there is a univariate frequency tables that organized for only one variable of interest, and bivariate frequency tables organized for 2 variables of interest. The third types of the tables is the relative frequency tables and cumulative frequency tables. In this section, we hope to learn how to make the frequency tables for quantitative continuous data and how to make bivariate frequency tables, and also how to make the cumulative frequency tables. Let's have an example. If we have the following data, organize the data in an appropriate frequency table using the class limits 40 up to 50, 50 up to 60, and so on till 90 up to 100. Then construct the ascending and descending cumulative frequency table for the variable and answer the following. What is the number of individuals less than 70? What is the number of individuals more than 50? In this example, he's giving you a quantitative data and continuous data. So the appropriate frequency table is the frequency table for a continuous data. And in order to make this frequency table, we should first define the range of this data. The range of the data equals the difference between the maximum and the minimum value in these data. The maximum value in these data is 98 and the minimum value is 40. So the difference between them is 58. And we can approximate this value to 60. So the range of the data is 60. And this is the first step. The second step is to define the number of the classes and it can be from 5 to 50. In this example, we can assign 6 classes. The third step is to find the class interval. And this by dividing the range over the number of classes, and this equals to 60 over 6 equals to 10. So the class interval is 10. So in constructing the frequency table for continuous data, there is 2 columns. The first column for the classes and the second one for the frequencies. And we will have 6 classes, and the first class, for the first class, the lower limit of the class equals to the minimum value in its data, which equals to 40, and the upper limit of the class equals to the lower limit plus the class interval, and this equals to 40 plus 10, so the upper limit of the first class is 50. So the first class would be from 40 up to 50, and so on till the end of the 6 classes. As we can see here, this is the frequency table. This is the classes and frequencies, and we have 6 classes here. The first class starts from 40 up to 50, and the second one from 50 up to 60, and so on till the end of the data, or till 100. The class interval here is 10. After that, we would set the frequencies of each class. The second requirement is to find the ascending cumulative frequency table from the data. Okay, again, back to our frequency table, we can see that our classes are as follows. From 50 up to 60, from 60 up to 70, from 70 up to 80, from 80 up to 90, from 90 up to 100. In order to make the ascending cumulative frequency table, we only take the upper limits of the classes. So we write less than and take the upper limit of the classes. But notice that we should start our ascending cumulative table with the lower limit of the first class and write less than 40. Then we add our frequencies. The frequency for the first class is always equals to 0, as there is no data less than 40, so the frequencies equals to 0. For the second class, less than 50, and these are the frequencies between 40 up to 50, so this equals to 2. After that, the frequencies for the class that less than 60 means the frequency of the first class 0, plus second class 2, plus third class 4, which equals to 6. So the frequency for the class less than 60 equals to 6, and so on till the end of the data. And we can see that the frequency for the last class equals to 40, which is the total frequencies. The ascending cumulative frequency table starts from the upper limits of the classes, but for the descending cumulative frequency table we take the lower limit of the classes. And again, our classes are 40 up to 50, 50 up to 60, 60 up to 70, 70 up to 80, 80 up to 90, and 90 up to 100. In the descending cumulative frequency table, we make our classes from the lower limits of the classes, and we write 40 or more, or the lower limit of the classes, or more than the lower limit of the classes. So 40 or more, 50 or more, 60 or more, and so on. Then the frequencies for the first class 40 or more, this means all the data, so the frequency for the first class is the total frequencies. and this is against the ascending cumulative frequency table, as the first class in the ascending cumulative table starts with 0 and ends with the total frequencies. In the descending cumulative table, we starts with the frequency of the total frequencies and ends with 0. For the second class, 50 or more, this means total frequencies 40 minus the frequency of the first class, which is 2, and this equals to 38. For the third class, the frequencies for the third class, which is 60 or more, means the total frequencies minus 6, which is the frequency of the first and second class, 2 and 4, and this equals to 34. For the fourth class, equals the total frequencies minus the frequency of the first class, the second class, the third and the third class, and this equals to 26. From 40 means 14, and so on till the end of the data. So the frequency of the last class in the descending cumulative table equals to 0. The number of individuals more than 50, so more than 50, have 38 frequency. Another example, given the following data about the age of the workers in a farm. Complete the missing values in the data and answer the following. This is the frequency table for the age of some workers working in a farm. Here is the frequency of each class, but if we can see that the last class, the frequency of the last class is missing, so we have to find it by adding the frequency of all classes and subtracting the value from the total frequencies, and this would equals to 50 minus 44, which equals to 6. So the frequency of the last class equals to 6. Again, the upper limit of the fourth class is missing too, so the upper limit of this class is the lower limit of the following class, and the lower limit of the last class is 40, so the upper limit of the previous class equals to 40. Question 1. If the maximum value is 47, the range of these data is, so the range equals the maximum value minus minimum value, and the maximum value here equals to 47 and the minimum value equals to 8, which is the lower limit of the first class. So the range equals to 39. The length of the correct answer is B. The length of the class interval is, so the length of the class intervals equals the upper limit minus the lower limit, and this would equals to 16 minus 8, which equals to 8. So the correct answer is 8, and this is C. The lower limit of the third class is, the lower limit for the third class is 24, so the correct answer is C. The upper limit of the last class is 48. The minimum value in the age data is 8, which is the lower limit of the first class. The number of frequencies at the last class is, the number of frequencies equals to 6 for the last class, which is the missing value we just find. The number of workers whose ages are less than 32 years old are less than 32 years means 5 plus 12 plus 17, and this equals to 34. So the correct answer is D, as this is the frequencies for the first three classes. Question 8. The number of workers whose ages are more than 40 years old, and this is the frequency for the last class, which equals to 6. The percentage of workers whose ages ranges between 16 and 24, and this is the second class, and the frequency of the second class equals to 12. So the percentage of this class equals to 12 over 50 times 100, and the correct answer is A. The type of the variable age is quantitative continuous variable. The level of the measurement for this variable is ratio level, so the correct answer is D. Another example, in a research study related to the relation between education and smoking, was found that there are 2 educated individuals are smokers from a total 5 educated individuals. If the total numbers of smokers are 10 individuals and the total sample size is 15 individuals, from the preceding information answer the following. So in this example, we are interested in 2 variables, the education and smoking. So we would use a bivariate frequency table. Okay. This is smoking, not smoking, or not smoker, educated and not educated, and total. Okay. There are 2 educated individuals and smokers. So at smokers and educated, we can write 2 from total 5 educated individuals. So we have total educated of 5, and 2 of them are smokers. So the not smokers are 3. If the total number of smokers equals to 10, the total smokers are 10, so and 2 of them are educated, so the rest are not educated, which equals to 8. And the total sample size equals to 15, so the non-smokers individuals equals to 5. 3 of them are educated and 2 of them are not educated, and the total not educated people equals to 10. This is the bivariate frequency table for education and smoking. The number of educated individuals. Question 1. The number of educated individuals who are unsmokers, so educated and unsmokers, this equals to 3, so the correct answer is A. The percentage of educated smoker individuals is educated and smokers, which is 2 over 5 times 100, this equals 4%. Question 3. The number of uneducated and smoker individuals, so uneducated and smokers equals to 8, so the correct answer is A. The percentage of uneducated and smokers individuals. Uneducated and smokers equals to 8, so the percentage is 8 over 10 times 100. This means 8%. The type of education variable is qualitative nominal, quantitative ordinal, quantitative discrete, quantitative continuous. As the education is a nominal, qualitative nominal variable, so the correct answer is A. The level of measurement for smoking variable. Smoking may take smoker or not smoker. So this is a nominal variable and can be measured at the nominal level of measurement. So the correct answer is A. Another example, in an experiment conducted on several rats injected with different vitamins A, B, C to examine whether infected or not, we get the following data. So this table represents the data about the experiment conducted on rats to examine whether these rats are infected or not infected, and the vitamins injected in the rats A and B and C. Let's first complete the missing data in this table. For the first row, which is the infected rats, we can see that the total is 30 and the missing value is the frequency of the injected with vitamin C and infected, and we can find these by subtracting the frequency of vitamin A and B from the total. So or the infected rat who is injected with vitamin A and infected rat injected with vitamin B equals 15. By subtracting 15 from 30, the rest is 15. And for the totals, the total of vitamin A equals to 30 and for vitamin B equals to 20, and this is 50, and by subtracting 50 from 70 we get 20. Also by subtracting 30 from 70, the rest is 40, and for each column 30 minus 10 20, 20 minus 5 15, 20 minus 15 equals 5, and the total here is 40, of course. Question 1. The number of uninfected rats and injected with vitamin C is, so this is uninfected rats and this is vitamin C, so the intersection between the uninfected rats and injected with vitamin C equals to 5, and the correct answer is B. Question 2. The total number of rats injected with vitamin C, all the rats who are injected with vitamin C, so we would take the total frequencies for the column of vitamin C, which is 20. So the correct answer is C. Question 3. The percentage of infected rats and injected with vitamin B. So infected rats, this is the infected rats and this is the vitamin B, so the intersection between the infected and injected with vitamin B is 5. So 5 over 30 5 over 30, as here we need the percentage of the infected rats, so the total infected rats is 30 and 5 of them are injected with vitamin B, so 5 over 30 times 100, and this equals to 17%. The percentage of total uninfected rats and the total of uninfected equals 40, and the total rats or the total individuals equals to 70 times 100, and this equals to 57. The type of the infection variable is a qualitative nominal variable, as it takes two categories, infected or not infected, and these are nominal variables, so it's a qualitative nominal, and the correct answer is A. The level of measurement for the infection variable is a nominal level of measurement, and the correct answer is A also. Example 4. Given a quantitative data with minimum value equals to 5 and the maximum value equals to 95, and we want to organize the data in a frequency table, knowing that the class interval length is 10, how many appropriate numbers of classes for the frequency table? In order to find the number of classes for the frequency table, so n, which is the number of classes, equals range over class interval, or class length. And in this example, the range equals difference between the maximum and the minimum values. So the maximum value here is equal 95 and the minimum value equals to 5 over the class interval length, which equals to 10. So 90 over 10 equals 9. So the appropriate class numbers equals to 9, and the correct answer is B. In a group of quantitative data with range 100 and the minimum value 100 and maximum value 170, the minimum value is, as we know, range is the difference between the maximum and the minimum, and the range equals 100, the maximum value equals 170, and we need the minimum value. So the minimum value equals 170 minus 100, and this equals to 70. So the correct answer is B. If the minimum value in a group of data, the minimum equals 15, and the maximum value equals 155, the range of these data, the range equals the maximum value minus the minimum value. So this equals to 130. And 40, sorry. So the correct answer is A. The percentage frequency for a certain class is 20%, and the total frequencies are 50. Then the original frequency of the class is, as the percentage, the relative frequency for a certain class equals the frequency of the class over the total frequencies, and the total frequencies here equals to 50, and the relative frequency here equals to 20%. So by multiplying the relative frequency times the total frequencies, so the frequency equals 20% times 50 equals 10. The percentage of a group of data equals 100, and the number of the class equals 5. Then the length of the class intervals equals, so the length of the class equals the range over the number of classes, and this equals to 100 over 5, which means 20. So the correct answer is C. The process of putting raw data in frequency tables achieves one of the statistics science aims, which is collecting data, organizing data, presenting data, summarizing data. Frequency table is for organizing data, so the correct answer is B. Question 2. Determine if the following sentence is true or false. The greater the number of the classes, the mutual exclusive property is achieved. This is of course false because the collectively exhaustive property is achieved, not mutual exclusive, as this means all the data are represented in the frequency table. The length of the class interval can be computed by dividing the range by the number of classes. This is true. The range of a group of data is the difference between the maximum value and the minimum value in the interval. This is true. Frequency tables can be classified into univariate and bivariate frequency tables according to the type of the variable. This is false because univariate and bivariate frequency tables are a type of tables according to the number of the variables of interest, not according to the type of the variable. In the process of organizing data in a frequency table, mutual exclusive and collectively exhaustive properties should be available in classes of variable. This is true. The frequency table of discrete quantitative variable can be considered as one of the frequency table according to the number of the variable. This is false, as a discrete quantitative variable is the type of the frequency table according to the type of the variable, not the number of the variable. Bivariate frequency table is a type of frequency tables classified according to the type of the variable. This is false, but the right answer is that the bivariate frequency table is the type of frequency tables classified according to the number of the variables of interest. Question 8. In the ascending cumulative frequency tables, the cumulative frequency for the last class is the total frequencies. This is true, as the ascending cumulative frequency table starts with frequency 0 and ends with total frequencies. In the descending cumulative frequency tables, the cumulative frequency for the last class is 0, and this is true also, because for the descending cumulative frequency tables, we start with the total frequencies and ends with 0. In the ascending cumulative frequency tables, the cumulative frequency for the first class is 0. This is true also, because we start with 0 and ends with total frequencies. In the descending cumulative frequency tables, the cumulative frequency for the first class is total frequencies. This is true, as we start with in the descending cumulative frequency table, we start with total frequencies and ends with 0. And this is against the ascending cumulative frequency table. Sentence 12. The percentage frequency can be calculated by dividing the frequency of the class over the total frequencies. This is true. Thank you for watching this video and hope it's useful to you. Good luck and see you at the next video.